okay, this Smith chart. Okay, but for this subject, what you learn only this type. Okay, so you didn't learn about the normalized. Okay, and then for this level, okay, for the degree level, okay, you will use this Smith chart. Okay, about this Smith chart, okay, when you want to make a matching, especially for the communication, okay, so you need to use this Smith chart. Okay, and then about this chapter, okay, they belong to the transmission line and waveguide. Okay, and then about the transmission line, okay, parallel plates, coaxial line. This one mostly involved with the communication, okay, with the very communication. And then what is very important is a matching. Okay, this one is matching. Why? Because they want to get maximum power transfer. Okay, this one. Okay, this one you want to get maximum power, okay, transfer. Okay, which meaning that the losses must be minimum, but they have a losses. And then what you learn is an ideal, which means that the losses you are not considered, but for the real implementation, there are losses in form of heat, okay, and then the power factor and so on. Okay, this one is an example, okay, for the transmission line. Okay, so you have a transmitter, okay, and then you transmit, and then for this antenna, this one is a dipole. Okay, dipole, which means that you have a up and down. Okay, and then if you only have one, it's a monopole. Okay, monopole only one. Okay, this one, this symbol. And then about this antenna, okay, if you want to learn about this length of antenna, is referred to the lambda. C, speed of light. F is a frequency, operating frequency. Lambda is the length of the antenna. So for the 5G, okay, 5G, the frequency is a very high. Okay, and then C is a fixed, okay, fixed value, because this value is a 3.0 times 10 power of 8 speed of light, okay, meter per second. And then if the frequency is very high, okay, so lambda, you can see this one, they are very low. Okay, so this wavelength, you see that the size of the antenna is a very short, okay, very low, okay, the length. And then about this one, advanced antenna design. So your smartphone, all your smartphone, I already told you, is embedded. Okay, embedded antenna. Okay, but they got antenna. Okay, all your smartphone. Because why? Because embedded. So for today, everybody doesn't like. Okay, if you see the 2G, okay, 2G smartphone, they got an antenna, especially brand Ericsson. Okay, this one is an antenna, but nowadays all flat. So your smartphone like this one, okay, and then inside here, okay, normally here is your antenna. This one is embedded, okay, embedded antenna. Okay, this one is the explanation what is a transmission line, okay. Okay, and then here, okay, parallel is a very simple. Okay, you have a parallel, and then okay, so this one is a very simple. And then the latest one is a twisted. Okay, you twist. Okay, so you can see the latest installation for the TMB power supply. They are twisted. Previously is a parallel. Okay, they are twist. Okay, and then the coaxial cable, like this one. About the special for the coaxial cable here. Okay, so the very special for the coaxial cable, outside the magnetic field is a 0. Okay, and then if you compare this one for the transmission line and twisted, this one is a parallel. Okay, so this one is a parallel, this one is a twisted. Okay, twisted with a magnetic field. Okay, if you compare Okay, if you compare the twisted, okay, the magnetic field for twisted is less than magnetic field compared to parallel. So that's why for today, TMB choose this one. Okay, this one is a twisted. Okay, twisted pair cable, the twist. Okay, so if you're comparing the length, okay, for the length for the parallel, compare for the length for the twisted. Okay, the length for parallel are less compared to length for the twisted. Okay, because they are, when you twist, they require a high length. Okay, so that's why you need to have more. Okay, for the length. If the parallel, they are less. Okay, if you're comparing, okay, their length, and then the advantage for the twisted, the magnetic field, this one is a less compared to parallel. And then if you compare to coaxial cable, outside the magnetic field is a 0. That's why for the astro cable, they are using coaxial cable. Okay, this one, okay, so it's an example. Okay, this one is an insulator, which means that this type material is not metal. Will not allow the current. Okay, so this one is a metal. And then this one, okay, the overheat, okay, overheat power supply. Okay, this one, the type is, they are made from aluminum. What is very special for aluminum is not, okay, they are not rusting, which means the aluminum, this one is an alloy. Okay, but the material, they are more made of aluminum, because if you're using a pure aluminum, their metal is not, the strength is not so good. Okay, so this one, they add, okay, make it aluminum alloy. Okay, and then they are not rusting. And then about this one, keep your mind, okay, you already learned, okay, the height for this wire. Okay, if the height is a very increase, which means that the operating voltage they carry very high. Okay, so please be careful. Okay, while you're living here, okay, so they carry high voltage. Okay, and then you already learned about magnetic field. Magnetic field caused by the current. Okay, if they have a current here, okay, so use your right hand, so that we produce magnetic field. Okay, and then this magnetic field proportional to current. Okay, and then the current proportional to voltage. If the voltage is an increase, your current is an increase, and then your magnetic field is increased. So they are not recommended, okay, you living near to this power supply if you have a choice. That's why, okay, for here, there are no house. One for the safety, and the one for this one, this reason. Okay, they have a magnetic field. And then if you exposure so many years, more than 20 years, they will be affected for your health. Because why? Because you are exposure to this magnetic field. Okay, so that's why, okay, in KL, okay, so you can see this one, the power tower, they change that shape of like a tree, artificial tree. Okay, but still they carry. Okay, they carry the power supply. For that's why all the residents they didn't like. Because why? Because of this one. Okay, magnetic field. Okay, might be some of your friend living, and then the new design just like a tree. They have a one pillar here, and then they have a power supply. Okay, and then the parallel plate, coaxial cable. Okay, here. Okay, and then I move on to the Smith chart. Okay, and then first, okay, you need to know, okay, about the location. Okay, this one is a Smith chart. Okay, this one I already give to you. Okay, and then this one, okay, the center is a 1.0. Okay, the center is a 1.0. And then this for the horizontal axis is for the real part. okay, for the real part. Okay, what you learn for the complex number, you learn about the complex number. Okay, you learn about the complex number. So you got for the y-axis is the imaginary, for the x-axis is the real, and then you have a 0. Okay, so if you, this one is a magnitude is A, this one is a B. So this is your location. So let's say, okay, your Z. Okay, your Z is the A plus JB. Okay, because this one is your imaginary. And then standardized for the engineering, we are using I. Okay, for the mathematics, you are using I. And engineering, we are using J. Okay, for the mathematics, we are using I, but they are same. Okay, okay, for the engineering, J, same also for the mathematics, I, same also, plus minus square root -1. So you got J squared equal to -1. Okay, this one is not something new for you, just a revision. Okay, so okay, so we go this one. So the location for the 50 ohm, okay, so you need to determine. Okay, before that, okay, for the Smith chart, you need to do a normalization. Okay, normalization is very simple. Okay, this one is a capital Z1, 50 ohm. You want to normalize, it's very simple. You will just divide by the 50. Okay, normally, if I'm not giving you what the normalized impedance, you just use 15. Okay, 50. If there are said that for the normalized value 60, you need to use 60, or the value also can be 70. But if I not tell you, you standardize, use 15. Okay, normally. But there have a cases might be for the normalized resistant value might be 60, might be 70. But for this case is 50. Okay, so you need to do a normalization. Okay, so here, very simple. Okay, when you do a normalize, you should use a small z. Okay, so small z equal to capital Z. Okay, Z1 divided by 50. Okay, so they are given 50, so you got 1. Okay, so okay, you got 1. Where is the location? Okay, you take out your Smith chart, the location, the center of Smith chart. If you zoom this one, okay, like this one. Okay, you should know how to locate, okay, the coordinate for the Smith chart. Okay, so this one, okay, take out your Smith chart. So you know that this one is the center for the Smith chart. Okay, so this one is a Z1. Okay, Z1. Okay, this one. Okay. Okay, next. Okay, you need to determine where the location for Z2. Okay, Z2 is a very simple. Okay, you just normalize. Okay, when you want to normalize, you should use a small z. Okay, so small z2 equal capital Z2 divided by 50. Okay, so Z2 is 50 minus J 25. Okay, divide by 50. So what the value you got? Okay, you got 1 minus 0.5 J. Okay, J you should write in front, not the back. Okay, here. Okay, the location standardized. Okay, and then you need to locate where the location 1 minus J 0.5. Okay, so okay, this one. Okay, so the location for Z2 is here. Okay, normalize. So how you want to locate? Okay, because okay, this one is a 1. Okay, minus. Okay, so the minus. Okay, you should know. Okay, this one is up. This one. Okay, this one is a for this positive j. Okay, and then if you start from here, you go down, this one is a negative j. Okay, so 1 are here. So the question is a 0.5. Okay, 0.5. Okay, you need to use this scale. Okay, this one is a 0.2. This one is a 0.4. This one is a 0.6. So you can know that, okay, in the middle, this one is a 0.5. So, okay, here 1 minus 0.5. Okay, 1 are here. Okay, 0.5. You follow this curve, and then you know this one is a 0.5. So locate this one. You just write down x. This one is a z2. Okay, this one is a small z, z1. Okay, after you normalize, you can use Smith chart. Okay, if you are not normalized, you cannot use a Smith chart. Okay, this one. Okay, this one is a z2. This one is a normalized. Okay, so a small z, not capital Z. This one is a z1. Okay, so this one is a z2. Okay, so based on the question, it's a 1 minus 0.5. Okay, 1 here. Okay, 0.5 are here. So this one z2. Okay, 1 minus 0.5. Because why? Because in the bottom here, half circle, here is a negative j. For the up here is a positive j. And then keep your mind, okay, this one is related to the characteristic of this one, okay, inductor and capacitor. Okay, inductor and capacitor, keep your mind, you should know that if you have a capacitance, what the impedance. Okay, for the capacitance, the impedance, okay, ZC is a 1 over j omega c. Okay, if you have a inductor, okay, this one you should memorize from now until forever. Okay, so this one, the impedance for inductor equal j omega L. Okay, and then what the value for omega? Omega is a 2 pi f. Okay, so 2 pi f, this one is the operating frequency, pi 3.142, or you can use the value for pi from the calculator. Okay, and then here also keep your mind, because of the z, this one zc here, also you can write, okay, negative j over omega c. Okay, so we see that for the capacitance, that we give value negative. For the inductor, that we give you positive j. Okay, and then how you want to get negative j? Why? Because this one you multiply by j, you multiply by j. So j squared, okay, j squared is a negative 1. Okay, j squared is a negative 1. So that's why I got negative 1 here. So if you got negative, show that this one they have element of the capacitance. Okay, if they got a positive, this one they have element of inductor. Inductor, okay, like this symbol, you just use a wire. Okay, they are like this shape. Okay, and then the capacitance is a parallel plate, the basic architecture for the capacitance. And then for the inductor, the basic architecture, you just winding the wire, and then they will acting as a inductor. Okay, like this one. Okay, and then next, okay, Z3. How you want to locate for the Z3? Okay, here. Okay, so it's the same procedure. Okay, you need to normalize. Okay, you need to normalize. So when you normalize, you should use a small z. Okay, Z3. Z3 here. Okay, capital Z3. when you want to normalize, okay, divide by 50. Okay, when you divide by 50, you got 1 plus j. 1 divided by 5, what? Okay, 1 divided by 5. You got 0.2, right? Okay, 0.2 j. Okay, 0.2 j. So for the Z3 here, okay, you see that this one, okay, the location. And then if you look about the Smith chart, okay, so 2.0 are here. Okay, 2 plus j 0.2. Okay, so 2.0 are here, okay, because this one is 1, 1.2, 1.4, 1.6, 1.82. Okay, and then plus, okay, plus 0.2. Okay, 0.2, okay, you see that this curve. Okay, because plus we using the up circle. Okay, because why? Plus j, you use this scale. Okay, so when you want to use this scale, okay, 2.0 are here, and then 0.2. Okay, same this curve. So this one is your location for Z3. Okay, so here you need to locate Z3. Okay. Okay, and then also I think the others, okay, you are very good. Okay, you can locate, okay, this one, and then I want to show to you, okay, about the short circuit. Okay, about the short circuit is very simple. You just have a wire. Okay, have a wire. This one is a short circuit. Open circuit, okay, you open. Okay, they are not connected. Okay, so this one is an open circuit. And then for the short, you just short. And then for the short circuit, Z, what the value for Z? 0. Okay, for the open, what the value for the impedance? This Z, what the value? Anyone? I give you a reward. Or are you sleeping? Okay, for the Z here, the value is an open circuit, is an infinity. Okay, so you need to locate where is the this short circuit, open circuit. Okay, so this open circuit is an infinity are here. Short circuit, Z equal to 0. The location are here. Okay, if you look zoom using a Smith chart, 0 are here. Okay, so this one is 0.1, 0.2. So 0 are here. So this one you can divide. Okay, because from here to here 0.1, here 0.05. Okay, this one is a 0. So this one the location for the short circuit. Okay, and then when they go up, okay, this one is a location for the infinity. Okay, this one. Okay, open circuit. Okay. Okay, we go fast. Okay. Okay, this one is example. Okay, how they want to find, okay, the impedance matching. Okay. Okay, first, okay, they got a Z 100 plus J 50. And then you need to do normalize. Okay. You need to do normalize. Okay, this one is small z, capital Z divided by 50, you got 2 plus J. Okay. So you need to locate where is the 2 plus J. Okay. So 2 plus J are here. Okay, 2 plus J are here. Okay. Okay, 2 plus J. Okay, maybe I use a new. Okay, 2 are here. Okay, plus J. Okay, I use a different color. Okay, from this exercise. Okay, I want to locate 2 plus j. Okay, so 2 are here. Oh, no, this one is a 1.0. Okay, until 2. 2 are here. And then plus j. Okay, you use this scale. Okay, this curve. Okay, 0.2, 0.4, 0.6, 0.8, 1. So where the location Z are here. Okay, Z are here. Okay, this one is a Z, small z. Okay, small z. Okay. Okay, and then here, okay, you want to do a normalization. Okay, and then take out your compass. Okay, this one is take out your compass, one in the center of the Smith chart, and then the one here. Okay, take out your compass, and then you draw a circle. Okay, you draw a circle. Okay, this one is the center. Okay, so you draw a circle. Okay, so because my this one I cannot. I try my best. Okay, I try my best to draw a circle. This center are here. Go back. Okay, and then okay, you just draw a circle. Use your compass. Okay, and then for this one, you need to print out. Okay, this is a Smith chart, and then you draw. Okay, using your compass. Okay, so this one is the center, and then your circle here must be go through this point. Okay, go through this point. So I need to keep bigger. Okay, so my lecture today is very slow. Why? Because okay, this you need to follow. Okay, the step. Okay, the step taken. Okay, so this one, okay, must be center. Okay, so I got this one. Okay, I got this circle, and then okay, take out your ruler, and then you should okay, your ruler. Okay, first point are here, second point are here, center, and then take out your ruler, and then you draw a line. Okay, you draw a line here. Yes. Okay, you draw a line here. Okay, and then must we go through the center and also this point. Okay, Z and okay, I zoom it. Okay, must be follow Z and the center are here. Okay, so I just highlight okay this line. Okay, so I need to go down. Okay, so there we go through the center for the Smith chart, also for the Z are here. Okay, and then when you draw this one, okay, you should find out what value, what the location are here. Okay, this location, okay, roughly okay around 0.4 minus 0.2. Okay, 0.4 are here. Okay, 0.4. Okay, let's say okay, this one is a because I'm using this one, it might be not accurate, but if you're using a compass, you should get around 0.4 minus 0.2. Okay, the location are here. Okay, so this one. Okay, so roughly around this one. Okay, 0.4. Okay, minus 0.2. Okay, so 0.2. Okay, this one. Okay, this scale. Okay, 0.2. So if you see, okay, if I follow my plot here, so I got, okay, this one is let's say, okay, I got around, okay, this one is a 0.4. Okay, this one is a 0.5. So this location I got 0.4. Okay, 0.1. Okay, minus, okay, around, okay, 0.1. Okay, so this scale, okay, 19. Okay, J. Okay, if you got this one, I can accept. Okay, okay, what I can say here, this one is a roughly. And then how, okay, this one based on the Smith chart. Okay, if you want to know, because why you got, you know that Z is a 2 plus J. Okay, if you want to get 2 plus J, okay, take out your calculator and then you tell me where you normalize, you using Y equal 1 over Z. Okay, take out your calculator and then you tell me what your answer. 1 divided by 2 plus J. And then your calculator must be turned on. Okay, they are complex number. Okay, what the value? Anyone? Okay, 1 divided by 2 plus J. What the value? Okay, so what the value? Anyone? Okay, the value supposedly you should get, okay, 1 divided by 2 plus J. What the value? Anyone? One divide 2 plus J. So know where the command. Okay, so this one I should gradient. Okay, so for this case here, okay, you should get, okay, where how is it? Anyone? Okay, take out your calculator. Anybody can give me an answer? Okay, 0.4 minus 0.2i, right? Okay, like this one. Okay. Okay, 0.4, okay, minus 0.2i. So I can want to say here, okay, they are equivalent, okay, for the Smith chart, okay. And then about this Smith chart, you are using this one based on the graph, okay. Based on the graph, what I want to tell you might be you have a very complex, okay, very complex calculation. This one is a very simple. Okay, so what I can say here, okay, when you want to normalize, you should get, okay, you divide by here, you should get, okay, 0.4 minus, okay, 0.2. Okay, so you can double check. Okay, you can double check. Okay, so when you want to plot, okay, this one is a opposite direction, you can get y. Okay, so the location is a 0.4 minus 0.2. Okay, and then for this case here, you can double check. Okay, you can double check how, use your calculator. Okay, use your calculator. So this location, after you do a normalization, 2 plus j. Okay, 2 plus j, and then you got y. Y is a reciprocal 1 over z. Okay, reciprocal 1 over z. So you should get 0.4 minus 0.2. Okay, here. Okay, and then this one is a formula. Okay, they have a formula. And then okay, next, okay, this okay, this one is they have a flow. Okay, they have a flow. So for this case here, what I want to tell you here, okay, you got z here, and then when you want to normal, you reciprocal, you got y. They are opposite direction. Okay, they are opposite direction from this point to this point. And then this, you draw a straight line. One point are here, one point are center, and then you make it very long. Okay, they touching this one and also this touching this one. Why? Because you want to read the scale. Okay, so you get 0.4 minus 0.2 j. Okay, and then next, okay, this one is an impedance. How you want to derive? Okay, how you want to derive? Okay, so take your paper and pencil or pen. You should draw this one. Okay, you should draw this one. Okay, because I will explain to you. Okay, this one is a very simple. Okay, because why? Because this lecture note I will not give to you. You need to draw. Okay, take out your paper, your pen. You should draw this one. Okay, and then this one is a power supply, and then they have a resistance, inner resistance Z, and then they have a load. Okay, whatever you want, you have a circuit. You want to give a power supply to the load. Okay, and then they got this length L, and then you want to find out, okay, what the impedance from the power supply. Okay, here, and then from this one is a real, the circuit, and then you can convert, okay, this circuit to become like this one. Okay, and then this one is a power supply, okay, VG, and then they got a inner, okay, inner resistance for the power supply. And then this L is a length for the transmission line. Okay, for the transmission line is length. Okay, transmission line. And then you want to give a power to the load. Okay, ZL. And then they want to find out, okay, from the source, what the impedance, okay, for this side. Okay, so this one, okay, the derivation, okay, source or input impedance. Okay, you already draw this one, yes or no? This one, yes or no? Okay, so
not yet.
Okay, you draw this one. Because this lecture note I will not give to you. You need to draw, okay? Okay, take out your paper and pen. Okay, you should draw this one because this is a derivation, especially if you involve with the transmission line. And then keep your mind, okay, you are deal about the cable. Okay, and then about the cable first, what I want to say here is a maximum for transfer. Okay, draw these figures, and then you should label all of this one. Okay, done. Okay, already done.
Done, Doctor.
Okay, hurry up. Okay, you draw these figures with the labeling. Okay, done. Yes or no?
Dah, Doktor.
Okay. Okay, next you should draw this one is a real implementation. Okay. And then from here, okay, you need to convert to the circuit diagram. Okay, draw this as circuit diagram. Okay, Z0 here is a transmission line. Okay, they have a length is a L. Okay, and then this one is a load. You want to give power supply to this load, whatever. Okay, whatever load you are here, might be lamp, motor, whatever. Okay, because you want to activate this load. Okay, and then they got a power supply VG, this one, AC. Okay, and then they got inner resistance for this power supply side. Okay, ZZ. And then you want to see what the sources, okay, the impedance. Okay, this one, the sources, they are combination with the ZO and also ZL. Okay, draw these figures. Okay, this lecture note I will not give to you. Okay, I give you a time, you need to draw. Okay, when you draw, you write down, you understand. Okay, because why? Because your handwriting. Okay, your handwriting, and then I will explain you step by step. Okay, very slow. Okay, already done. But don't worry, before 12:30, I will stop, okay, my lecture. Okay, tomorrow night, I will give you a revision class. Okay, tomorrow night, same online, okay. Don't worry, before 12:30, I will stop, okay, my lecture. Okay, done.
Done, Doktor.
Okay. Okay, and then you should write this one. Okay, Z, okay, X equal to 0, ZS. For the X equal to L, is become ZL. Okay, and then for the ZS is source or impedance, input impedance. Okay, and then for the ZL is a load impedance. And then for the Vx here is a V incident exponent power of E negative lambda X plus V reference E power, this one E is an exponent, okay, 2.71. Okay, lambda X positive. Okay, how they got it? This one from the communication engineering. Okay, so they got this formula. For your task, you no need to derive how to get this one. Okay, for your side here, you need to know how to use this formula. Okay, so for the Vx is a V incident INC multiplied by E. E is an exponent. The value you can take out from calculator. So the value is E equal to 2.71. Okay, not a power for the MATLAB. E is a power, 10 power of something. But for this case, E is an exponent. Okay, 2.71. Okay, this one is the power, they got a negative. That's why I put a circle. Okay, to not to do a mistake. Okay, don't miss to write negative. Okay, this one is a lambda X. Okay, V reference multiplied by E lambda X. This one is a lambda. Okay, done. Okay, and then the next, okay, what is a lambda? Lambda is equal to alpha plus J beta. Okay, this one alpha plus J beta is a propagation constant. Okay, and then for the alpha is an attenuation, ATTEN attenuation, and beta is a phase change. And then J, this one same, okay, equal to plus minus square root negative 1. Okay, this is a propagation constant. Okay, already done. And then this one, okay, you should put in bracket. Okay, in the bracket, red color, show this one is very important. Okay, so if you see alpha, this gamma, okay, this gamma, you know that this gamma is alpha plus J beta. Okay, so this one. Okay, so next. Okay, this one is a current. Okay, so the current I incident. Okay, short form. Okay, capital I and C. Okay, so short form, you read this one, equal to V incident E power of negative gamma X. Okay, divided by Z naught. Okay, I reference, this one is a current. No, I reflected. Okay, I reflected equal to V reflected multiplied by E power of gamma X divided by Z naught. Okay. Okay, this one reflected. Okay, reflected. This I is an incident. They are reflected back to the source. Okay. Okay, done. If no answer from you, I assume that you already done. I can go to the next formula. Okay, already done.
Yes.
Okay.
Yes, sir.
Okay, for the x equal to L, where this one? Somehow x are here. Okay, x equal to L for this point. Okay, for the x equal to L, VL divided by IL, you got ZL. Okay, because this one from the Ohm's law, V equal to IR. Okay, ZL is an impedance. Okay, so you just put inside the formula. Okay, so V incident plus V reflected E power of 2 omega L, okay, divided by V incident minus V reflected E power of 2 omega L. And then for the IL is a I incident minus I reflected. Or the short form is the REF. Okay, done. Okay, already done. Okay, you should write step by step. Okay, done.
Yes. Done, doctor.
Okay. Okay, not forgot to write this one, Z naught. Okay, Z naught here. This one is in bracket, which means that they are multiplied by to the Z naught here. Okay, and then for the I at the L location equal to I incident minus I reflected, REF. Okay, REF here is a stand for the reflected. Okay, done.
Yes, doctor.
Okay, next. Okay, for this case here is a source. Okay, source equal to Z. Okay, where is the Z? Here. Okay, the source. Okay, location Z equal to 0. Here. Okay, and then when the Z equal to here, okay, for this one, okay, ZS, okay, equal to V incident, okay, plus V reflected divided by V incident minus V reflected. Okay, which means that L is a 0. Okay, L is a 0 here. E power of 0 what? 2.71 power of 0. What the value? Anyone? I give you rewards. E power of 0 what? Because why from this here? This one, okay, 1. Okay, that's why this one become 1. So plus V reflected. Okay, already done. Okay, already done. This one. Okay, if you don't answer from you, I assume that you're already done. Okay, next. Okay, and then here, okay, V reflected divided by V incident. Okay, okay, this one, okay, from the formula, you just use it, which means that ZL minus Z0 divided by ZL plus Z0. Okay, and then in bracket multiply by E power of 2 omega L. Okay, so this one, okay, so Zs equal to Z0. Okay, so you got this one. Okay, okay, you write down this one, this formula. Okay, please be careful because this one they got a negative. But don't worry, I will not ask you how to derive. Okay, don't worry. I will not ask you how to derive, but for your task, you should know how to use it. Okay, how to use it. Okay, so for the Zs equal to Z0, okay, Zl plus Z0, okay, in bracket, they multiply by E power of negative gamma L. Okay, plus Zl minus Z0, multiply in bracket, multiply E power of omega L, and so on. Okay, here. Okay, you just write down this formula. Okay, and then you learn about the in calculus. Okay, in calculus you learn. So E power of plus minus omega L, C also equal to cos, okay, omega L plus minus sinus. Okay, this one is a sinus hyperbolic, not a sinus. Okay, sinus hyperbolic change omega L. Okay, and then this one, when you want to expand, which means that E omega L equal to cos omega L plus sinus omega L. If you got this one is a negative, this one is a negative. Okay, cos omega L minus sinus omega L. Okay, write this formula. Okay, for the sinus, this one tangent, okay, tangent. Okay, so not tangent, okay, tangent, okay, this one is a tangent, which means that hyperbolic, okay, hyperbolic tangent. Okay, so you got, okay, Zs equal to Z0 in bracket, Zl plus Z0 tangent, okay, omega L. This one is a omega. Well, no, this one is a gamma, okay, gamma, alpha, beta, gamma. Okay, so this one is a gamma. Okay, this one is a gamma, okay, gamma L. Z0 plus Zl tangent, okay, gamma L. Okay, because why? Because alpha, beta, gamma. Okay, they got a pair here. Okay, already done. Yes or no?
Yes.
Okay.
Done, doctor. Done, doctor.
Okay, this one, okay, for the losses, okay, so this case here, for the losses, okay, case, okay, alpha is a 0. So the gamma here, alpha, beta, gamma, okay, gamma equal to 0 plus J beta. So you got J beta, okay, for the lossless case, okay, alpha is a 0. So this one, okay, gamma, you put inside, okay, you put inside this one, this formula, and then you got Zs equal to Z0, Zl plus J, okay, Z0 tangent beta L. Okay, and then you got Z0 plus J, Zl tangent beta L. Okay, write down this formula. Okay, but don't worry, this one they have an extra explanation. But what is very important, I want to show you, especially in bracket here, is a very important, okay, the relationship. Okay, so because normally we are very seldom using tangents. Okay, so for this case here, for the case alpha is 0, there are no more tangent. are no more tangents. Okay, they're hyperbolic tangent. They are already absolute. Okay, tangent beta L. Okay, write down this formula. And then keep your mind, okay, when they have a formula, they have an assumption. They have an assumption. They want to make it simple. Okay, for this case here, it's a losses. Losses, ideal case. Okay, for the ideal case, alpha is a 0. And then next, okay, what happens if the ZL is a 0? ZL load is a short circuit. Okay, we know that for the short circuit, it's a 0. And then from this formula, you just put inside, okay, 0 here. So you got 0. And then this one is a 0. So whatever you multiply by 0, you got 0. Okay, you put inside the formula inside here, you got J Z0 tangent beta L. So this one is a reactive. Okay, which meaning that this one is an inductive because positive J. If you got negative, okay, this one is a capacitive. Okay, write down this formula. Okay, and then keep your mind, okay, for the beta, okay, they are same with the 2 pi divided by lambda. Okay, for the beta. Okay, keep your mind, okay, beta, okay, is a, you can expand what the value is a 2 pi divided by lambda. Lambda, this one is a left wavelength. Okay, lambda. Okay, already done. Okay, and then what happened? If ZL here is an infinity, if this one is an infinity, show that this one is an open circuit. Okay, so the open circuit, okay, so you put ZL is an infinity here. Okay, ZL infinity here. Okay. How they got this one? Negative J Z0. Okay, divided by tangent beta L. How they got this one? Okay. Okay, you should know that this one is a ZL is an infinity, which means that this one is a short circuit. No, open circuit. This one. Z infinity is an open circuit, which means that, okay, they are open. Okay, not connected. So that's why they got Z1 here is infinity. The current will not go flow. Because why? If they have an air, this one is infinity. The current cannot go flow. And then for this case here, okay, for this case here, okay, Z0 is a 0. So this one is a short circuit. So you got this one, you got this one. They are short circuit. They are connected. And then here, for this case here, ZL is an infinity. So you put inside here, ZL infinity. So how you got this one? Negative J Z0 divided by tangent beta L. Okay, so how you got? It's a very simple. You just divide by the ZL. So you got Zs equal to Z0. Okay, you divide by ZL, you got 1 plus, okay, plus Z0 tangent. Okay, no, we not use this. Okay, we use this formula. Okay, this not use the up formula, we use this below. Okay, so you got Zs. Okay, so you got Z0. Okay, in bracket, you divide by ZL. This one you got, divide by ZL, you got 1 plus J Z0 tangent beta L. Okay, you divide by 1 over Z. This one you divide by ZL. Okay, and then when you got 1 over ZL. Okay, 1 over ZL. Because this one you divide 1 over ZL, you got 1. Okay, right? This one Z0 divided by ZL. So below is a Z0. Okay, you plus J tangents is it J tangent beta L. Okay, you got this one. Okay, and then for this case here, okay, whatever value you divide by infinity, what you got? Whatever value you divide by infinity. Okay, whatever value you divide by infinity, you got okay, this one, okay, you got this will go to the 0. Okay, and then this one, whatever value you divide by infinity, ZL is infinity. You got this one is a 0. Okay, so you got okay 1. Okay, so you got this one. Okay, I just follow equal to Z0 multiply 1 1. Okay, right, and then you got J tangent beta L. Okay, and then this one you multiply by J, below you multiply by J. So that's why you got negative J Z0 divided by tangent beta L. Okay, because J squared is a negative 1. So negative 1 J Z0 divided by tangent beta L. Okay, so for the any other load, okay, ZS equal to ZR plus J ZJ. Okay, you already write this formula. Yes or no? Okay, write this formula. Okay, already done. Yeah, yes or no? Okay, this one, okay, you got this one, okay, and then for the any other load, the standard formula is a ZS plus ZR plus J ZJ, okay. And then next, okay, for this case here, ZL, okay, write this formula. Okay, write this formula, okay, this one is a small z, okay, so capital Z divided by Z0. Okay, so you got ZL plus J Z0 tangent beta L. Okay, and then you divide by Z0 plus J ZL tangent beta L. Okay. Okay, write this formula. Okay, keep your mind, I already told you that, okay, for if I not given to you for the standard value for the Z0 is 50 ohm. But some of the cases, okay, the value for the Z0 can be 60 ohm or can be 70 ohm. Okay, this depends to the question. They will state, if they are not tell you, you can use 50. But in the question, they say that you should use Z0 60 ohm, you should use 60 ohm. Okay, but for the standard, they are using 50 ohm. Okay, already done. Write this formula. Already done. Okay. Okay, this one is a tau. Okay, tau, straight line. Okay, and then you have this line and then this line. Okay, tau equal to ZL minus Z0 divided by ZL plus Z0. Okay, you multiply by E power of 2 gamma L. Okay, this one is a gamma tau. Okay, this symbol is a tau. And then about the ZS here, source. Okay, then we see. Okay, what the impedance here. Okay. Okay, already done. And then same, okay, gamma equal to alpha plus beta. Okay. And then alpha plus beta for the lossless, okay, with the previous formula, alpha is a 0. So we can write gamma equal J beta. Okay. And then for the beta here, okay, beta equal to 2 pi divided by lambda. Okay, this one, okay, normally, okay, if they are inside this tangent, the unit is a radian. You cannot use degree. Okay, you should use radian. Okay, for the tangent. Okay, you should use a radian. Okay. Okay, already done. Okay, already done. Okay, for the tau here, okay, the relationship is a tau naught, okay, in a modulus, okay, which meaning the magnitude multiplied by E power of -2 alpha L. Okay, they are multiply E J alpha minus 2 beta L. Okay, you just write down this formula. Okay, I will not ask you how to derive. Okay, but what is very important, you should know how to use it. And then for this one, okay, you can simplify. You should get, okay, tau E J theta. Okay, so this one, E J theta. Okay, already done. Okay, already done.
Yes.
Okay. I think this one is a same. Okay, for this case here, okay, for the plus and minus, okay, for this side, okay, positive Jx, below is a negative Jx. Okay. Okay, and then next, okay, for the series, same, we use Ohm's law. Okay, so for the total Z, you just add, okay, for the Z connection, Z1 plus Z2. And then for the parallel, okay, we use this one, Ohm's law. Okay, so for the Ohm's law, okay, so you got 1 over Z equal to 1 over Z1 plus 1 over Z2. Okay, so this one, you can also, okay, Y equal to Y1 plus Y2. Okay, make it simple. Okay, after you got Y, what's the relationship between Y and Z? Is a Z equal 1 over Y. Okay, now also you should know that Y equal 1 over Z. Okay, this one. Okay, Ohm's law. Okay, this one involved with the formula. Okay, so I think a lot the explanation. Okay, this one I think takes more than 1 hour. Okay, so okay, what I want to tell you here. Okay, so you use this formula, you try. Okay, you try, and then this length from here to here is a 0.1 lambda. Okay, 0.1 lambda, and then you should try to use this formula, and then there are given load here. So load 0.4 plus J 0.5 ZL. Okay, and then you put a J tangent beta L. Beta is a 2 pi over lambda. And then the L, they are given 0.1. Okay, the L is 0.1. So this one, okay, and then for the tangent, you should use a radian, not degree. Okay, so radian. So beta 2 pi over lambda. L is a 0.1 lambda. So you cancel this lambda, cancel. 2 multiply by 0.1, you should get 0.2 lambda. Okay, and then you plus divide by 1 plus J ZL. Okay, this one is a load. Okay, 0.4 plus J 0.5. Okay, you put 0.5, and then for the tangent, same, beta L. Beta L is a 0.2 lambda. And then take out your calculator, you should get 1.25 plus J 1.35. Okay, you do it now. Okay, do it now. And then if one of you can same got this answer, okay, so show that you understand. Okay, try it now. Take out your calculator. And then you should memorize this formula. Okay, this formula is a very important. This one. Okay, this formula you should write down in your lecture note. Okay, so this one, they are given L, you can measure ZS. Okay, with the distance 0.1 lambda. You know that this one, the value is 1.25 plus J 1.35. Okay, or 1.36 I can set. Okay, do it now. Anybody can get this answer. If you cannot got this answer, you have got a problem how to press your calculator. And then your calculator need to turn on complex number, and then your degree change from digit to radian. Because why? Because this tangent, they are measured in radian. They are not measured in degree. Okay, try it now, and then if you can get the answer, show that you understand. And then you press the calculator in the correct way. Okay, try it now. Okay, siapa yang dapat answer? Who got the answer? Okay, for the quiz, yesterday I will give you assignment. Okay, for the quiz, I will give you a take-home quiz. Okay, one day. I will try my best. This week, I will give you quiz. Okay, tomorrow night, I will give you a revision class. And then reminder, you need to sit for the final exam for my subject. Okay, anybody can get the answer? Who got this answer? Same. Or you can get 1.35 or 1.36, I can accept. Okay, who got the answer here? Anyone? Tengah tekan. Okay, reminder, if you cannot get same answer with me, you have a big problem how to press your calculator. Okay, and then your calculator, you need to turn on the not degree. Okay, you should change to radian, because this tangent, the angle measure in radian. And also you need to turn on your complex number. Okay, and then for the mathematics, they are using I. For the engineering, we are using J. Okay, all of you need to try, and then make sure you know how to press your calculator. And then the final answer 1.25 plus J 1.36. This one beta L, this one they measure in radian. Okay, beta is this one is fixed. Okay, 2 pi divided by lambda. L is the length. Okay, in the lambda. Okay, for this question, L they are given 0.1 lambda. So 2 pi. Okay, so you got 0.2. Where you got 0.2, 2 multiplied by 0.1, you got 0.2 pi. Because this one is a pi. Lambda cancel. Okay, because this one 2 pi over lambda, you cancel, you cancel. You should get 0.2 pi. Okay, pi, this angle measure in radian, not in degree. Okay, siapa dapat lah jawapan? Who got the answer? Okay, reminder for international student, you should press your calculator. Make sure you got this answer, 1.25 plus J 1.36. Okay, who got this answer? Apa ni jawapan? If you got a syntax error, what happened to you? You are already third year student. And then this, how you want to press the calculator should be covered in mathematics. Okay. And then I already told you that your calculator, you should change, okay, the angle, change to radian, not in degree. And then you need to turn on your complex number. Okay, if you have a syntax error, dapat. Dapat. Siapa dapat? Siapa yang dapat? Siapa dapat? Ismail.
Saya dapat.
Okay, ni Ahmad. Okay, ni Ahmad Wajdi. Okay, you dapat, show that you understand. Okay, so siapa yang tak dapat, who doesn't know, okay, can ask your friend. Okay, but make sure you know how to press your calculator. Okay, don't wasting your time do it manually. Okay, because why? Because in the final exam you can bring your calculator. Okay, don't wasting your time. What I want, okay, for this side here, don't wasting your time. First, you need to give me a full formula. Okay, like this one in bracket. And then next, you should put the value inside. Okay, the ZL, this one. 0.4 plus J 0.5 in bracket, close bracket, plus J. Okay, and then J, beta L. Okay, beta, okay, 2 pi over lambda. So you just write down 0.2 lambda pi. Okay, because you need to write L equal to 0.1 lambda. So the tangent here, this one they measure in radian. Okay, not in degree. And then 1 plus J are here, same. ZL 0.4 plus J 0.5. You just write down. And then the tangent same with the above and below. Tangent 0.2 pi. Okay, and then you just write down here, and then you just straightforward give me the answer. Okay, no need to simplify. Okay, don't wasting your time. Because why? Because for the test you are fighting with the time. Okay, don't wasting your time. So you should give me this final answer. Before that, you should give me the formula, and then you should put the value inside here. And then from here, I know that you are using calculator. Okay, so you are using calculator, you can get this answer. Okay, don't waste your time. What value you got? Okay, 1.247, and then if you change to 2 decimal place, you got 1.25, right? Okay, and then for the J, what the value you got? For the J, what the value? Okay. 1.35 what? 1.369. 569. Okay, so 1.3569. Repeat again, what is value? Okay, 1.3569. Okay, you change to two decimal place, what the value you got? Yes, like this one, 1.36. Yes. Okay, reminder, when you are using your calculator, okay, so you got more than two decimal place. Okay, so for the final answer, you just give me 2 decimal place, enough. Okay, so the maximum is a 3, okay, decimal place. Minimum 2 decimal place. Okay, this one is a reminder, not just for my subject. Okay, the other subject for the engineering, they are very important. You don't need, even your calculator can give you 9 decimal place. Don't write 9 decimal place. When you want to write down your answer, minimum 2 decimal place, maximum 3. I think enough. Okay, don't wasting your time. But when you put inside the formula inside here, you got more than 3 decimal place. You should use that value. But for the final answer, okay, for this case, they are not given to you. You should use 2 decimal place. Or if you are very hardworking, okay, you can write 3 decimal place. Okay, but for this case here, standardized 2. It's not recommended you write 1 decimal place. Okay, so this one, okay, like your friend said, you change to the 2 decimal place, so you got 1.25 plus J 1.36. Okay. Okay, and then here, okay, so this one, okay. Okay, this one, okay, what I want to tell you here, okay, 0.4. Okay, so I think this one is the last, okay, 0.4. Okay, 0.4 are here. Okay, 0.4 plus J 0.5. 0.4 plus J 0.5. Okay, they are here. 0.4, 0.4, 0.6. So in the middle, they are here. Okay, they are here. Okay, and then you should draw a circle. So I change the color. Okay, I change the color. Okay, so this center, the circle for this center are here. And then there must be go through this point. Okay, go through this point. So I need to rearrange, okay, because this cannot give me the circle. Okay, that just give me the oval shape. Okay, but I can, what I can say here, rearrange, okay, rearrange the shape as long as it look a circle. But if you print out, use your compass. Okay, use compass, you need to get exactly, okay, circle. Okay. But this one, okay, what I want to show to you. Okay, so the center here, okay, you see must be in the center. Okay, so I need to make it bigger. Okay, so roughly, okay, like this one. Okay, so this one, okay, roughly, and then, okay, for this case here, back to the question, okay, first point, it must be follow this one, okay, must both follow this center, okay, for this straight line. Okay, so I need to rearrange back. Rearrange and then make it very long, okay, outside the circle, and then this one also, okay, outside the circle. Okay, this one. And also, okay, we go back to the question, and then for the length is a 0.1. Okay, the length is a 0.1. So this one, okay, when you rate, okay, for the half circle, this wavelength 0.0 are here 0.25. Okay, so here 0.07, 0.08. This one is a 0.09. So here, okay, we can say that, okay, this one text, okay, this one is a 0.082, okay, lambda. Okay. Okay, 0.082 lambda. Okay, lambda like this one. Okay. And then here, okay, there will this follow, okay, and then you need to know what the value for the ZS here. What for the length is a 0.1 lambda. Okay, so 0.1 lambda, what you need to do, okay, so 0.082 plus 0.1 lambda, so you got 0.182. Okay, so you got this one 0.182 lambda. Okay, so 0.182. Okay, this one is a lambda. Okay. Okay, so you need to find out, okay, where is a 0.182 lambda? Okay, 0.182 lambda, they are here. Okay, they are here. Okay, they are here, right? Okay, 182 lambda. They are here. Okay, they are here. And then same, take out your ruler, and then you should use a different color. Let's say green. Okay, so this one, this point. So this line, okay, I use a different color. Must be follow this point, and also in the circle, the center for the circle. Okay, this one. Okay, and then I zoom it. Okay, so I zoom it. So must be exactly touch 0.0. Okay, 0.0182. Okay, 182 are here. Okay, so okay, this one. Okay, so I want to find out where the cross section point. Okay, from this circle, also for this green line. So I got this one. Right. Okay, I got this one. Okay, I got this one. Okay, I got this one. I think I should use a circle. Okay, this one. Okay, this is a cross section. Okay, cross section point. Okay, between this circle and this straight line. And then what's this value? Okay, what this value? Okay, you see that. Okay, this one. Okay, 1.2 are here. Okay, 1.4 are here. Okay, and then in middle here is 1.3. So you see that this point are around, okay, 0.12, what the value? 24. Okay. Okay, 0.124 here. Because why? Because this circle, this curve is a 1.2. This curve is a 1.4. And then this middle, in the middle here, okay, 1.3. So they are here. So we can say that around 1.24. Okay, here. And then this one, okay, the next is part J. Okay, part J, you see that this one is a 1.2. Okay, this one is a 1.2. From here, okay, to here. Okay, 1.2. And then 1.4 are here, from here to here. Okay, so there are, okay, and then we see this one is 1.2, this one is 1.4, this one of course we know that this one is a 1.3. Okay, so there are here. Okay, so which means that plus J 1.3 around what value? Okay, 1.3, okay, 36. Okay, okay, let's say 1.36. Okay, so here. So you compare with your answer here. So from the Smith chart, okay, from the Smith chart, then we give you 0.124. And then from the calculation, this one is a correct answer. Exactly. Okay, but if you're using a Smith chart, okay, if you got this one, I can accept. Okay, 0.124 plus J 1.36. So you got here. Okay, 1.36. So what I want to tell you that this one is a calculation. Okay, so this Smith chart. This one, the method you are using Smith chart. So if they have a question, ask you to use a Smith chart to get this value, you should use this method. And then also you can double check. Okay, use this formula. Okay, that's the reason. Okay, so you can use this formula. Okay, this formula, there are correct answer. But you should know that if this question they ask you to use Smith chart to get this location. Okay, this is their method. Okay, so you get that this one, okay, they got a same value. Okay, I think I need to stop my lecture. Okay, any question? Okay, I will give you a security code. Okay, tomorrow night I will give you a revision class. Okay, security code is a Smith chart. You are given 5 minutes to fill online attendance. Okay, any question? Okay, reminder, your security code for attendance is a Smith chart. Okay, and then see you tomorrow night. Okay, sekian, terima kasih.
Thank you, Doctor.
You're welcome.
Thank you, Doctor.
Thank you, Doctor.